Anyone? How do we solve for t?
Would we divide by 1.056?
No, we cannot do that.
Okay.
Anyone else?
We would have to take the t root based on whatever t is. Oh, I'm not sure.
It was a sweet try. We apply the inverse function to both sides. Let's go back to our first page. Second page. What did we say was the inverse of the exponential function? Anyone?
Logarithmic.
So we'll have to apply log to both sides. So we apply natural log to 2 and natural log to 1.056 raised to power t. Let me explain this. Let me refresh your memory. Apparently that kind of went away. So let me explain. So log function has 3 properties. Here's one. Log base A of a product. And I'm going to write it in a minute. The second one, log base A of a ratio. And this is what I want for that. Log in any base of a number or quantity to a power. That goes in front as a factor. So this is B multiplied by log base A of X, of A. So this is the difference, and this is the sum of 2 logs. Log of A plus log of B. Of course, all are the same base. And this one is log of A minus log of B because it's a ratio. A minus log of B. So these are the major properties. There are other little properties here and there about for log, but these are the major properties, if you want, of the log. This is not our case because we're not applying log to a product or a ratio, but we're applying log to a power. So every time I apply log to a power, the power goes in front as a factor, meaning it's multiplied. That's what we mean by a factor. So coming back to my problem here, I have that natural log 2 equals t times natural log of 1.056. Now all this is a linear equation. Only in a linear equation I can divide, and now I can divide. This is a number, don't get if you want, it's a fancy number, but this is just a number. And where are my rest of my props? Rest of my props disappeared? No, got it. Okay, and these are just 2 numbers. How do I get t? Well, obviously I divide this by this. So they look fancy, but they're just simple numbers. So then t equals natural log 2 over natural log 1.056. So that's how we enter this in the graphing calculator. So let me share my screen. And we have natural log 2 and divide by natural log of 1.056. So 12.72. So roughly t equals 12.72 years. So if nothing changes and she doesn't withdraw the money, etc., 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 then she will have at the end of 12 years, roughly at the end, almost 13 years, she will have in the account $40,000. Good. have you chosen any problem from the previous ones, differentiating, or we continue? Anyone? Anyone?
Could we do 23?
Yes. So 23. I see it. Is it the 1/2 e to negative 5x?
Yeah.
Very good. So g of x, 1/2 e to negative 5x. So this is just the constant. So when I differentiate this, I keep the constant in front. This is e to a function. Oh, oops, sorry. E to a function prime is e to the function times the function prime. So this will be e to negative 5x multiplied by this prime. Can anyone tell us how much is negative 5x prime?
-5.
That's it. So I will rewrite it as g prime as negative 5 over 2 e to negative 5x. Very good. Any questions? Good pick. Anything else? Okay, so I would like to talk about the log functions and their derivatives. And that will be the end of chapter 3. There is nothing else there. So this is section 3.2. The first one was 3.1. So the exponentials is just 3.1. This is 3.1, and this will be 3.2. Just to make sure it's clear. And that will be the end of chapter 3. So log functions. We already graphed them at the beginning on page 2, and we also discussed the major properties. So let's go directly to differentiating. So if a function is given as natural log x, simple log, the derivative of this function is 1 over x. Now, if the function is, let's say, natural log of g of x, which is function composition, and I want to differentiate, of course, like we had before, 1 over g of x multiplied by g prime. Here I should have written times x prime. Why don't I write x prime? Can anyone explain why I don't write x prime?
Because it's 1.
Because it's 1. Exactly. But here I cannot omit it. So now let's practice this, and then we'll look at other problems. On page 319, any problem you would like from 57 through 90? I will choose the first one, and then you will choose the next one. Yeah, why not? 79. In 79, we have a function that is natural log of x squared minus 7 divided by x. And you could say this is a mess, and I will have to agree for several reasons. First of all, this function is a ratio, and then I have to differentiate a ratio. So first 1 over the ratio, it will flip the fraction, and then I still have to use the quotient rule to determine this. Okay, so then f prime will be 1 over this. 1 over x squared minus 7 over x times this prime, using the quotient rule. Okay, so the denominator is squared. The top function prime times the denominator minus the top, don't forget parentheses, or you make sure you distribute a negative sign, times x prime, but that happens to be 1. So I don't have to write the 1. But now I have to be careful because the negative has to be distributed to these two terms. At the same time, I'm going to flip this fraction. 1 over a fraction is the multiplicative inverse, x over x squared minus 7. So I will continue. So then f prime equals x over x squared minus 7. Leave it alone for now. The denominator is x squared here, but this is 2x squared minus x squared and plus 7. I like this because I can eliminate one x from the top with one x from the denominator. I will continue combining like terms as x squared plus 7. There is an x in the denominator. We never multiply factors in the denominator. So please, especially with the midterm, do not be tempted. I'm not going to deduct points, but it's a waste of time to distribute x or multiply the factors in the denominator. So please don't do it. Because before we look at word problems, please choose any problem with natural log. Now, all the other problems, I didn't mean to skip them, but it's up to you. 1 through 55, 1 through 56, or algebra. They're algebra problems with logs. If you need to review any of that, I will definitely go for it. If not, I will choose 85, unless you want to choose 85. And please choose the next one. So g of x equals natural log x to the 4th power. So this is a function raised to a power. I didn't ask any questions on this, please. Anyone? Any questions on this problem? Okay, let me know. So g prime, remember it's a function to a power. I bring the power in front, I subtract 1 from the power, and then I differentiate the inner function. So that is 4 natural log x to the 3rd power times the inner function prime, which we just learned is 1 over x. You don't have to do anything. This can stay as is, really. Or just rewrite it like this. There is no need. This is fine too. Now, 87 is an interesting situation. Would you like to choose? Is anyone choosing? In 87, we have natural log of natural log. So this is f of x, natural log of 8x. Don't look inside yet. So when we differentiate this function, I have to write 1 over whatever is covered here. I don't care what it is, I'm just going to copy it. Times. Now I reached here. I need to differentiate this function of this. So that will be 1 over 8x. Times. Now I have to differentiate this, which is 8. So this is the outer function, the inner function, the innermost function. I differentiate this, then I differentiate this, then I differentiate this, and all of them have to have product. So, of course, I will simplify, get 1, and I have 1. I will put x in front of the natural log of 8x. Any questions so far? What would you like me to do next? Word problems or more practice of this? Anyone?
I don't have my book pulled up, but could you do another example of like one of the ones you just did?
Yes, like which one will be? Which type? A product, function composition?
The function composition.
Oh, yeah, you know what? Let's do a product. We didn't do a product. And then function composition again. Very good. This one has function composition as well. So 89. In 89, I see g of x equals natural log of 5x times natural log of 3x. So first of all, this one is function 1 and this function 2, so it's a product. And also function composition, because 3x and 5x are functions. They're not plain x. They're functions of x. Okay. Even x is a function, but you know what I mean. Okay, so then, I think I'm on page 8. Okay, so we're applying the product rule. So g prime, the first function, prime, is 1 over 5x times the inner function prime, which is 5, and times the second one, plus, I don't have enough room, so I'm going to continue here, plus, copy the first function times the second one prime, which is 1 over 3x, times the inner function prime, which is 3. Nice, because these two go away, and these two go away. So, however, I can't do much. I can only rewrite the natural log 3x divided by x plus natural log 5x divided by x. You could write it as one fraction because it's the same denominator. Natural log 3x plus natural log 5x. You could also condense the numerator. It's this property that we mentioned a few minutes ago that can go back and forth. This one. So if I have a sum, I can condense it back into this. So log of 3x plus log of 5x is log of 15x squared. You multiply these two. 15x squared, so you can write it. Let me write it since I showed it. So this is log of 15x squared divided by x. There is no need, this is good enough in this situation.